Hi, welcome to Mrs. Park's Algebra 1 class. We are moving on to Chapter 4, Section 5, Scatter Plots and Lines of Fit. Okay. So we've learned about scatter plots and lines of fit a little bit in pre-algebra last year. So when you have a scatter plot, which is just a graph with some scatter points across the graph, excuse me, there are some relations in the graph. So if you have a scatter plot that's going upward, the trend is going up. As x increases, y increases as well. And there's scatter plots on this graph. That's called a positive correlation. It's going upward. As one increases, the other increases as well. That's a positive correlation. When you have one as x going up and n is going downward, that's called a negative correlation. And then when you have something that's just scattered all over the place, doesn't really have a pattern, it's called a no correlation. Okay, for example, here, wages. Determine whether the graph shows a positive, negative, or no correlation. If there's a positive or negative correlation, describe its meaning in the situation. So here you can see it's going upward. As x increases, y increases too. So that's a positive correlation. Now, what does this mean? Here you see x as hours. So you see as the number of hours increases, the y, which is wages, the amount of wages, the money increases as well. So the graph shows a positive correlation. As the number of hours worked increases, the wages usually increase. Okay, this is going to be a nice short lesson. Okay, so using a linear function to model data. So one, you're going to make a scatter plot, determine whether any relationship exists in the data, such as positive or negative or none. Step 2, draw a line that seems to pass close to most of the data points. Step 3, use 2 points of the line of fit to write an equation for the line. Step 4, use a line to fit to make predictions. Okay. Alright, so here's an example. So what you're doing here is with the scatter plot, you're going to just draw a line that goes past like the most of the points. It doesn't have to necessarily pass the point, but you want to go through the closest. Okay, the closest to most of the data points. Alright, so here is a example. The Kingda Ka roller coaster at Six Flags Great Adventure in Jackson, New Jersey has broken 3 records. Tallest roller coaster at 456 feet, fastest at 128 miles per hour, and largest vertical drop of 418 feet. The table shows the largest vertical drops of 9 roller coasters in the United States and a number of years after 1988 that they were open. Identify the independent and dependent variables. Is there a relationship in the data? If so, predict the vertical drop in the roller coaster built 25 years after 1988. So here's your data. Okay, so years since 1988, a vertical drop in feet. So the independent variable is the year, because that does not change. Depending on the year, the vertical drop changes. So the vertical drop is the dependent. And as you can see here, as the years pass, the vertical drop in feet has gotten higher as well. So with the scatter plot, you just draw a line that goes through most closest to those data on the graph. So with this line, you're going to write an equation. So there's 2 points they can choose here. They chose 2 and 150 right here, and then 12 and 300. So you're trying to find points that are most close, like on the dot here. And with those 2 points, you're going to find the equation, and you do that by doing slope equation, y2 minus y1 over x2 minus x1, and they give you a slope of 15. With that slope, you're going to write it in slope-intercept form, by first using the point slope form. So choose a point, doesn't matter which one it is. Here the textbook used 2 and 150. So 2 and 150 goes there. They used 15 as the slope that we found here. And you're just rearranging using distributive property and found y equals 15x plus 120. With this equation, what are you going to do? They wanted you to predict how many feet it's going to be after 25 years. So if this continued, the trend, so 25 years will be about here. It's going to reach a lot higher. So instead of x, you're going to put 25. 15 times 25 plus 120. So we're going to predict it's going to be about 495 feet 25 years after 1988. Okay. So the scatter plot, this section has a lot of real life scenarios. It makes it more fun. Here I see another example. Use a scatter plot to find the approximate number of United States travelers to international countries in 1996. So here's the years and since 1990, and here's the thousands of travelers. So every year it seems like there's more people traveling. Okay. So with this, you draw a line, and then with this line, you're going to find a slope using the slope form, the slope equation. And then with this slope, you're going to put it in a point slope form, okay, with 1 point, and write it in slope intercept form. Then, of course, they're going to ask you to predict, and you use this equation to predict 6 years. So put, instead of x, you put 6, and that's how they made their calculations. Okay. But more importantly, I want you to know if it's a positive trend or a negative trend or no correlation, and then based on that, you can find your slopes. Okay. So here, tickets and prizes, the more tickets, the more prizes, positive trend. Here you have height and 3-point percentage made. So at the NBA, if you're taller, because based on your height, your 3-point percentage made gets lower, and that's a negative trend. Okay, so this is the lesson part of 4 or 5. Go on to next video to have some practice with 4 or 5. Okay, thanks for watching.